What you'll soon see is that around the step 500k, we see the divergence, right? So up until 500k, the new run inherited all the metrics from the parent run. So we see that end to end, but then it started to run much more smoothly. Now what you can see is that we have something that allows me to see if the gradient is kind of like unproportional to the weights of this layer, and it is, right? Like I still get these spikes. They're small, but not really that small. They're much more pronounced than everything else around them. So given that this is just a few layers at the end, what I'm actually going to do is try to resume this training from a checkpoint somewhere around 500k before it started going badly, and fork it to run in parallel to this main training. I don't need to stop this main training just yet. Maybe it will recover. Maybe these are just few weird samples, and the loss will kind of like resume convergence after a while, but I'm not so sure. So I want to run both in parallel and see how it goes. All I need to do to kick it off is just copy the name of this training to make sure I have it. And then I'm going to go into my training script. I'm going to paste it as the parent run ID. And when I'm creating this new Neptune run that loads from checkpoint, I'm going to specify the parent run ID and the fork step of 500,000 steps, at which I am forking from the main run that we've been watching before. So the script then is roughly the same as it was before. It just loads the checkpoint instead of initializing the model. And when I run it, you'll see that Neptune actually allows me to inherit all the metrics of the parent experiment up to the forking step, and then see the difference between the two runs. So that way I can track the lineage of all the changes, all the decisions, and all the metrics affected by those decisions in Neptune end to end, as I'm adjusting the parameters during a very long training run, which is very often required if you're running for weeks. It's just impossible to foresee every possible scenario and every possible change to parameters, such as the gradient clipping that we introduced here. So now that it's logging, I can go back to my report. I can see the new run is already running here now. So I'm just going to add it. You can see that it differentiates between runs through this dotted line versus solid line. You can change that to colors as well if you want to, but since we're only comparing the two, I prefer the lines. And what we can see here is, well, the metrics aren't available for multiple runs because there's like no definite way to aggregate those. But what you'll soon see is that around the step 500k, we see the divergence, right? So up until 500k, the new run inherited all the metrics from the parent run. So we see that end to end, but then it started to run much more smoothly. So let's watch it for a while. Let's see if that solves our issue and recap what we did in this short demo. Now, few more days have gone by and we can finally compare the forking results of the new run with the results of that original long run that had those gradient explosion issues. So here I'm looking at the same comparison dashboard. Let's zoom in on that one chart and the period after we forked the run. So you can see that the dotted line, which represents the new run, is continuing to converge smoothly, while the other one has this like spiking issue. The same goes for the eval loss. We actually see continued convergence on the new run, so that makes me hopeful that as we continue this run for a bit more, it will converge fully, maybe with few more updates. So yeah, hopefully this short example illustrates how debugging works in Neptune. If you run such a training run for a bit more time, you probably will end up with something like this. This is a dashboard from another LLM pre-training that we ran a while back. So you can see that there's a bunch of issues with various early runs, and then they are resumed with different settings, tuned, improved, and they continue all the way to convergence at the end.